You know, it's got to be one of the biggest questions we can possibly ask. It's this deep, profound mystery that every single one of us carries around inside our own head every single day. What is consciousness really? It's a question that has stumped humanity for, well, forever. And in the next few minutes, we're going to take a journey to the very edge of what we think we know.
No, I mean really stop and think about that for a second. When you think the word I, what are you actually referring to? Is it your body, your collection of thoughts, your memories? It's that feeling, right? The feeling of being an observer, a subjective self, right at the very center of your own personal universe. That's the mystery we're diving into.
Okay, so just to make sure we're all on the same page, we need a solid starting point. And this is really the core definition we're going to be working with. See, it's not just about being awake versus being asleep. It's about the experience of it all. It's the taste of your morning coffee, the feeling of the sun on your skin, the raw sensation of just being alive.
But before we can even think about looking for answers inside the brain with all our fancy science, we first have to figure out what questions we should even be asking. And for centuries, that's been the job of philosophers. They've been drawing the map of this conceptual maze, and let me tell you, their questions are absolutely profound.
And this is the big one. This is the Mount Everest of the entire field. It's what they call the hard problem. And it's not about the easy stuff, like figuring out what the brain does, how it processes information or controls our bodies. The hard problem is about why. Why should any of that electrical and chemical processing feel like anything at all from the inside?
And this is where things get, well, just plain weird. Think about the color red. We can explain the physics, right? We can talk about light waves of a certain frequency hitting your retina, sending signals up your optic nerve. That's the quote-unquote easy part. But why does all of that complicated biology produce the private, internal, subjective feeling of seeing red? That inner quality, what philosophers have dubbed qualia, that is the absolute heart of the mystery.
And believe it or not, the hard problem is just the tip of the iceberg. Philosophers also wrestle with things like the binding problem. I mean, how do all the separate streams of information, sight, sound, touch, get woven together into one single unified reality for you? Or what about the inner privacy problem? This one's a little unsettling. How can I ever be truly sure that your internal experience of the world is anything like mine? Any one of these is its own massive enigma.
So, when you're faced with questions this big, it's no surprise that people form a couple of major camps. Historically, you've got dualism, which is the idea that the mind is something non-physical, almost like a ghost in the machine, totally separate from the brain's hardware. And then on the other side, you have scientific materialism. This is the view that the mind is simply what the brain does. It's an emergent property of all that complex physical activity. And for the most part, modern science operates from this second viewpoint.
All right, so let's run with that second idea for a bit. If we assume the mind is a function of the brain, well, the next logical step is to go looking for it in there. So we're going to leave the philosopher's armchair and step into the neuroscience lab to see how scientists are searching for the biological roots of our own awareness.
Now, I love this quote because it just nails the challenge perfectly. We're not looking for a single consciousness spot in the brain, like a little light bulb that turns on. No, we're looking at a dynamic, constantly changing, unbelievably complex system of billions of interacting parts. Honestly, it's less like a computer and more like a weather system inside your skull.
So how in the world do you even begin to watch this brain weather in action? Well, scientists have some pretty incredible tools. You can think of things like EEG and MEG as these super sensitive microphones listening in on the brain's ridiculously fast electrical conversations. And then you have fMRI, which is more like a heat map. It shows us which parts of the brain are working hardest, demanding more oxygen and blood flow, when you're thinking or feeling or just looking at something.
And this is what's so incredible about a tool like fMRI. We can literally watch networks in the brain light up as a person remembers a childhood vacation or feels a pang of sadness. We're actually starting to create a visual map of the mind at work, turning these abstract internal processes into something we can see and study on a screen.
And it's crucial to get this, they're not just mapping a location, they're mapping a process. Scientists are studying something called neural population dynamics, the shifting patterns of activity across huge groups of brain cells. The best way to think about it is like the brain's operating system. It's the underlying software that runs everything, from your ability to pay attention to your memory.
Okay, so watching the brain is one thing. But what if we could actually build one? Or at least build a model of one that works the same way?
Well, that's the next great frontier in this quest, computational modeling, trying to actually create a blueprint of the mind inside a computer.
And it turns out there are a few really cool ways people are trying to do this. You've got neural networks, which are inspired by the brain structure, and treat it like a powerful learning machine. They're great for modeling stuff like memory. Then there are dynamical systems models. They see consciousness less as a physical thing and more like a stable pattern that emerges, kind of like a whirlpool that forms in a flowing river of brain activity. And then you get into the really wild stuff, quantum-like models. These suggest our mental states aren't fixed, but exist in a fuzzy, probabilistic state, only snapping into a definite reality when we make a choice, which is a bizarre idea that might just help explain our sense of free will.
But, and this is a big but, a really challenging idea comes out of all this modeling work. Some theories actually suggest that consciousness might just be an epiphenomenon, basically a useless byproduct. Think of it like the heat coming off your laptop's processor. The heat is there because the processor's working hard, but the heat itself doesn't do anything. In this view, consciousness is just the exhaust fumes of our complex brain. It has no real influence at all.
So, wow. Where does all of this leave us? We've taken a whirlwind tour through philosophy, into the neuroscience lab, and through the world of computer science. It's pretty clear the quest to understand consciousness is far from over, but the path forward, the map itself, is definitely getting a little clearer.
And now you can kind of see how all these pieces fit together, right? It's like a three-part quest. Philosophy draws the treasure map, it defines the mystery, and tells us what we're looking for. Neuroscience gives us the shovels and the high-tech scanners to start digging in the physical brain. And computational modeling is like trying to build a working replica of the treasure chest itself, just to see if we can figure out its secrets. You absolutely need all three if you want to have any shot at cracking this code.
Which brings us to one last mind-bending thought to leave you with. Let's just say, one day we do it. We succeed. We build an artificial intelligence that claims to be conscious, that acts conscious, that passes every single test we can throw at it. How could we ever really know if there's an actual subjective first-person experience happening on the inside? And that question? Well, it brings us right back to the very beginning, to that inner privacy problem. And it just goes to show you how deep this incredible enigma really goes.